Today I'm going to explain some aspects of correlation tests and how it works in clinical practice. When we want to demonstrate that there is association between two quantitative variables, for example, ice cream sales and temperature, we can use linear correlation. First of all, it's important to realize that a correlation does not mean causation. It only means that two variables are connected somehow, and the causation of one of them could be due to other factors. So, back to ice cream sales and temperature, if you want to see if there is correlation between these variables, we first need to build a scatter plot graphic. We can already notice that the dots create an ascending line, showing us that a positive correlation could exist. But how to calculate this? We use the Pearson's correlation coefficient for data with normal distribution and equivariances. We use this formula to calculate the coefficient. This coefficient results in a number between 1 and minus 1, meaning that the closer you get to number 1, the more perfect is the correlation. Additionally, depending on the number you get, you can estimate the degree of correlation. For example, correlation coefficient of 0.8 means a marked degree of correlation, and so on. But is this enough? Even if you find a strong correlation between two variables, you need to test this coefficient. This test of hypothesis is based on a t-distribution and compares the sample correlation coefficient with the correlation in the general population. Assuming that the coefficient in the population is 0, or the null hypothesis, and choosing the level of significance of 0.05, we can determine the critical t-value based on a table of t-distribution, according to the degree of freedom. Finally, getting the calculated t-value, we compare with the one in the table to accept or reject the null hypothesis. For example, if we get a t calculated of 1.74 and the critical t-value of the table is 2.45, we can accept the null hypothesis. In a nutshell, when you notice that there is a correlation between two variables, you need to verify the degree of correlation first and to test if this correlation is true. Thank you very much, guys. I hope you enjoyed this video.